Hi everyone, thank you for joining this live today. We are doing 15 days of SQL where every day for 15 days we'll be looking at certain blogs, certain tutorials, and then coming together in this live session of 30 minutes, revising all of those topics and getting hands on by practical questions in SQL. First of all, if you have made it today, showing up is half the battle done. So, congratulations for that. And secondly, if you have been following me throughout this 3 day journey out of the 15 days, congratulations, you are done with 20% of the cohort. And soon, I hope this has added value to your life and your data analysis journey. I hope this will be helpful more in the coming days. Today, getting back from what we learned yesterday is operators, arithmetic operators, dealing with things that compare, then dealing with things that create an entire new value after two columns. Now we'll be dealing with slowly transitioning forwards to things like logical operators. What logical operators do is they check depending on, like, before when we had just comparison operators, we were just checking between two values, if one was higher, if the two were equal, if one was lesser, if one was not equal to. Whereas in arithmetic operators we were transforming the columns by performing certain arithmetic operations on them to create a new derived column. However, when you have a need that you need to check logically a value whether it is equal to something or not, but it is not as straightforward as just putting a little equal to, or whether they are less than or equal to, or greater than or equal to, or not equal to. Sometimes the values are not as good, as well compared like we would want them to. For example, if I want to tell you that, okay, I want all of the months, like we were practicing yesterday, that I wanted just the January month or just the February month. So if I tell you that, okay, I want all of the months between March and December, do you think that putting a simple comparison operator would be able to perform that function? Why not? Because there's some limitations to it. If it is comparing, they both first of all need to be in the same scale. Now, in which scale can March and April be compared together? Maybe they'll be compared by how the alphabets occur. So it'll say that March, the letter M occurs after, and in April, the letter A occurs before. So it'll say that April is lesser than March. But that is not the real world relation or the logical relation you require here. You essentially want April to be ranked higher than March, right? So there are some real world relations which cannot be just translated using the comparison operators or the arithmetic operators. For those, we use such logical operators which help us essentially deal with such real world relationships and deal with data which we are not quite aware of. Like, if I give you a data with a billion rows, I don't think you'd be able to go down and see what is the kind of data which the table actually possesses. And oftentimes, while cleaning data, wrangling data, you would have to select a particular type of data, a data that follows a particular pattern. For those kinds of things, we have this very interesting, very useful concept in SQL called pattern matching. And it is implemented using the clause like. This is what we'll be learning today. Again, the example which I gave yesterday was, for example, if I want to know from a student database all of the students whose names start with J, okay, the letter J. Now, is there any way that I can use comparison operators or arithmetic operators to help me get that value? If there is, you can type it in the comments. I'll be looking forward to the solution. However, in all these 5-6 years of practicing SQL myself, I have never come across a scenario where for such a situation we required those kinds of things. So, in such situations, we'd be using the operator like and the concept of pattern matching. So, it only has essentially two steps here, and the two symbols which we use is percent. What percent does is it'll say that okay, there is something here. It can be one character or multiple characters, but there is something here. I don't know what it is, but if it is following this pattern, like if I say J and a percent, so what it will mean is everything that starts with J and has something after it would be taken. So percent just represents a placeholder. It acts as a placeholder for anything, and anything that matches a pattern like this will be printed or filtered out. The second character which we use in pattern matching is underscore. So what underscore does is it represents just one single character as opposed to percent which uses single or a string of characters. It can be used to identify either of them. However, if I say, okay, I want the names of those students who have a 3-letter name. So what I'll do is I cannot say percent there, because if I say percent, I don't have a control over the length of my pattern. Whereas, since I know that the underscore here represents just one single character, when I want 3 characters, I would say simply 3 underscores. Okay, let's go ahead and practice. So everyone please open your mode tutorial. It's a very convenient way, no matter if you have a laptop or not, or you have an SQL database set up. You can always use this to practice on their data right from your online browser. So this is the tutorial I'll be following. I've posted a link in the chat box for anyone who's interested. The link is also in the link is also present in your 15 days of SQL schedule. So if you're following that, you can directly go over from there. If everyone is ready with their setup, let's go ahead and start practicing hands-on. Again, don't make this a theory session. Don't just listen to it like a movie. I mean, I know this is not as interesting as a movie. It'll never be. But still, don't listen to it just theory-wise. Practice it somewhere if you're writing. Just something that gives you results out of it. Write code. If you don't get hands-on, you'll never be able to know what it was like. A simple character here and there, a simple press of the keyboard can lead to entirely different results or no result at all. So get hands-on, practice it. And so will I with you. For example, here, when you see the like operator, here they want Snoop. So we all know whose name Snoop starts from in the Billboard music chart dataset. So now what they want here is when they say select star, let's decode this query. What is this? Getting the information from my previous videos. If you have not checked them out yet, the playlist is right there on my channel. Go check them out. But I am hoping that you're already aware of this. If you're not, it's okay. I'll explain again. What the first statement here is doing is select is used to pick the columns. Here's a revision for all of those who already know. If instead of telling the column names, you just put an asterisk, it will treat that all of the columns present in the data set are to be selected. Okay. Next is the from clause. The from clause is used to specify where the columns are to be fetched from. What is the database? What is the name of the table? Those are specified using database name dot the table name. Next, now we have the where clause. What where clause does is it Let's use specify a condition, and if that condition evaluates to true, that row is selected, otherwise it's discarded. We have dealt with where during our comparison operator lecture, where we were saying if we want our destination city to be New York, or if we want our total flight time to be greater than 60. So what were we doing when we were specifying that? We were giving conditions, and in case those conditions evaluated to true, that particular row was getting selected. If for any row the condition evaluated to false, it was not selected in our select statement. So now here the where clause lets you specify function. A condition. What is the condition here? This. Group like Snoop. It rhymes. So what group here is? Group is essentially a column. I think once we'll print out all of the data set, we'll know what it was, but it is a column here. What it contains, we'll be able to see in just a few minutes. So there's a table, Billboard Top 100 year end, and it has a column named group. Now you'd see that when we were earlier using column names, we were just writing them as is. So why is this group surrounded by double quotes? So I think yesterday when we were dealing with strings, I told you that whenever we need to specify some keyword that SQL uses in as a name of our column, we need to tell that it is a column name and not a keyword. So group is a keyword reserved in SQL. So if you just use group as is, SQL will think it's a keyword and it is supposed to perform some functions, which we don't want here. Group is our column. To specify that it is column and not a keyword of some function, group by is a function. We'll be dealing with it later in this cohort. We surround it by double quotes. Okay, so this is the name of a column. Then the like operator, which we were talking about, what like does is it checks whether the value of a column is like some pattern or not, and the pattern is this. Now again, this pattern is a value given by you, the user, and not something that SQL used essentially. So it's a string and you would be surrounding it with single quotes. Inside the string, what do we have? We have Snoop. So we know that we want something that has Snoop in it. And now that it has a percent after it, what we are trying to tell SQL is Snoop and then something if it is followed after Snoop, if it can be one character or multiple characters or no character, you have to select that. You have to select all of the column values, all of the rows entries where the column group is like the pattern that says start with Snoop and then have anything after it. That's what percent specified, right? A single character or a string of characters. So let's practice with the question. Try it out. Hi Harry. Glad to have you all here. Okay, the workspace is ready. What was the table which we were using? It was this. Okay. So first let us check. Also, just a quick question from all of you. Would you want the query report which I practice here as a link in the description here so you can follow later in case you ever want to come back to this video? In case you want to, let me know. I'll save it accordingly. So what are we doing here is first we want to see what is the type of data which we have. So we'll be doing select star. Star will say that I want all of the columns. From will say where I want those columns from, which is my tutorial Billboard Top 100 year end. I copied this from here by the way, so you can too. Now we know we have a column named year, year rank, group, artist, song name, and ID. So it has 6 columns, and we have printed all of the columns, all of the rows without any filtering here. So now that we know what the table actually has, let's go ahead and have a new query where we practice this question out. What the question says is, first of all, what is the practice problem? It says write a query that returns all rows for which ludicrous, I'm sorry for my pronunciation, I am not from that part of the world, was a member of the group. So we just want if ludicrous was a member of the group or not. How do we get what are the people in the group? First of all, I can artist. I feel here in artists, yeah. In artists, I think we can see whether ludicrous is here or not. Because when there are two artists, it is saying Bachanan and Goodman. I feel the column artist is what we want. Let's see if it works or not. So again, what will I be doing? I'll say select star because I want all of the columns, because there was no particular cap to how many columns I have. Next, I'll be specifying where I want those columns from. That is my tutorial billboard top 100 year end table. Next, I will add the condition. The condition here is that ludicrous should be the member of the group. And now that we know that the name of the group members are present in artist. So let's say where artist, we have the column name. Next, what we'll do is, also how do you understand the column name was actually a keyword is when you say group, you see it will turn into red, and red is for the reserved column names. So we don't want to use it. So we'll enclose it within double quotes. Okay. But that is not the case here. We just want artist. And now we'll say artist and match the pattern because we don't have any ultimate value which we want to compare it against. We just want ludicrous to be a part of the group, a member of the group. So we'll say like, and now we'll say a string ludicrous. The thing here is that, okay, ludicrous should be within the artists. However, I don't know if the artist names would start with ludicrous or they'll end with ludicrous. So what I'll say is, let the person sign be both of the places. That ludicrous can be anywhere in between. I don't know whether he is at the starting or he is at the ending, but he can be anywhere in between the string, and that string should be accepted. Now let's see if it works or not. It does, and it's selected. Oh, I think the group was what we needed to do because the artist essentially is ludicrous everywhere. So let's see if it works with group. This is again some subject matter thing. It is not related to SQL. Now let's see if it works, and then we'll compare it with the solution, whether it helped in any way or not. We have the results, and now if you see closely at the column group, you'll see that all of them have ludicrous somewhere, maybe at the starting, maybe just standalone, maybe at the end. So somewhere in between. Now here it has ludicrous in between. But no matter what, where the position of ludicrous was, if the string or the name ludicrous was present anywhere inside group, that particular row entry was selected. Let's match it with the solution. They have the same thing. Now let's practice. Next thing it says is write a query that returns all rows for which the first artist listed in the group has a name that begins with DJ. Can anyone guess what the pattern here should be like? What they want is the first occurring artist, the first artist should have their name start with DJ. So now here you have a set of characters which should be present inside the pattern, and you also have the position of where those characters should be. Anybody? Okay, no problemo. Let's start again. Same rules. Select star from my table where, now I'll say I want group, and when I write group I'll say it's a keyword. So I will, to tell SQL that it is actually my column name, I will add double quotes around it and then say like, because like is the operator which is used to match patterns. The pattern here would be, since it is specified that we want DJ, the first artist should have the same name that begins with DJ. So I'll write a string DJ, and where will the person sign will be? At the end, because I want anything that starts with DJ. So there should be nothing before D, nothing. It should start with the words D, the letters D and J, and whatever has to come after it can, but nothing can come before it. Also some TED talk here, that nothing can come before you. I'm sorry about that. So now you see that the group which is selected is DJ Cool, DJ Sammy. When you scroll down, you will see for all 13 rows which it has filtered out, there is just one common thing, that everything has DJ ahead of it. Let's confirm with the answer. So turns out we were correct. Very good. Is everyone clear till here? Shall we go ahead with a little advanced concept from this? Okay. So now I want all of the artists who have a 5-letter name. Why? Because I maybe just love 5-letter names. So I'll say 5 letters. Now the second, I have a quantifiable number, which means I cannot use percent. Why? Because percent does not have any limit to it. It will select one character, it will be the wildcard for 0 characters, it will be the wildcard for 100 characters. It doesn't care what is the length. You can never put a limit for the percent wildcard. However, when we use the underscore, we know that it is representing only a single character always. So I'll write 1, 2, 3, 4, 5. When I write 5 underscores, I know that they are going to only stand for 5 characters and nothing more than that. So now my column artist would be compared against a pattern which is made up of 5 characters, any 5 characters, but they can only be 5 characters. And now you see, whatever artist we got, Timeless, SX, Kinks, Beards, Kings, Sony, Doors, Keith, Cream, Dells, Smith, Mercy, Bread, Ocean. Everyone is Queen, Rufus. Each one of them has a name of just 5 characters. Now, in case, okay, I like 5 character names, but I only want 5 character names that start with the letter B. Okay, so now I want 5 character names which start with the letter B. So B is my first character, right? Now, if I wanted any length of names, I would just say B and percent. So anything that starts with B would be selected. However, that's not what I want. I want just 5 letter names. So B is 1 character, so I'll have 4 character left. I'll go 1, 2, 3, 4, 5. Oh, sorry, 4. 4 underscores, because B is the first character, that is where it should start with, and that is something I have specified, so it's not like I can give it a wildcard underscore and it can accept any value it wants. I only want everything that starts with B. So now you see, you said you had birds, bread, bells, boys, brick, everything that started with just B and had 5 characters. So because for the rest of the 4 characters, I had given a placeholder of underscore. So it said start with B and then no matter what you have, it should just have 5 in total and 4 after B. Start with B, have 4 after it, no matter which 4, but the starting should be B. Now this is the case when we are using like. I hope the clause like is clear. Anand, I am just getting to it. What if something has to come before DJ? Will it be like this person DJ? Exactly, Aruku. That's how it'll be. If you want everything to end with DJ and there should not be anything after DJ, then you would say, okay, I would want percent, so something before, but the last 2 letters should always be DJ. And Anand, regarding you, why the solution has I like is what we are going to discuss now. So I here used ludicrous as is, right? As ludicrous appeared, that is L is capital and then everything else. However, this I could do because I knew that ludicrous is a name, it's a noun, and nouns start with a capital letter. However, what if this was something like a tree, right? So tree could have capital T or it could have small t. What would I do then? Then I don't have any limit to what the case of the character should be. They can be uppercase, they can be lowercase. If there are some programmers here, they can be snake case, they can be camel case, they can be in any case. I just want these alphabets or these letters or these characters to be in them in any case. Then what I do is I use the case sense, not like is case sensitive. So to make it not case sensitive, we have another operator called I like. Okay. What I like does is, even if there's a ludicrous which starts with small l, it will still ask it, it will still make it appear. Oh, sorry, I just ran the selected part. There's no change here because ludicrous always appeared in this format, that is L capital U D A C R I S small. But for places where we don't know how the case is going to be and it can change, so we don't want our condition to be case sensitive, we use the case insensitive I like. I like does not care what the case of your pattern is. It will just say if it finds those letters LUDACRIS in your solution, in your column value, no matter what case they are in. So when you want it to be specifically case sensitive and follow the exact pattern with the exact case that you want, you'll be using the operator like. You can substitute it I like you if you want the results to not be case sensitive. Okay? To give an overview of what we went through today was our first logical operator, that is like. What like does is it helps us specify a vague pattern that our column value might follow, and then everything that the pattern matches is extracted out of our database. How do we specify those columns? By the means of two characters, which is percent. Percent is used to represent no character, a single character, or a long string of characters, no matter what their length is. What underscore does is the second character which we use in our pattern matching. Underscore represents a single character. So there has to be one character there. It won't compromise on no characters or a long list of characters with no limit. No, there has to be one single character there. So every time you want to control the length of your pattern, you will be using underscore. Next, the third and final concept which we learned today was, what if we want our results to be present no matter what case they are written in? Because every time we scrape data, collect data, or enter data, there is always a chance of data inconsistency. And we don't want our query or our analysis to suffer because of that. So, to make our query inconsistency proof, we'll be using I like, which is case insensitive, and it will extract all of those queries, all of those rows which have that combination of characters, no matter which case they are in. Okay, so that's it for today. For those of you who have not yet joined the 15 days of SQL challenge, please head on to my Twitter. The link there would be on my channel page, and I'll post a lot of content regarding SQL, data analysis. You can follow it, get tips, reach out to me there, and become accountable of what you want to do. Thank you all for joining. Congratulations on completing 20% of this challenge, and hoping to see you again tomorrow when we discuss tons of this stuff, another logical statement again. That'll be, I think, let me check. I've scheduled so many videos, I have forgotten what I have scheduled. But today we did like pattern matching. I hope it was clear. If any one of you has any doubt, this is your time. Post it in the chat or tag me on Twitter. I am very active there. Yeah. Today we have like, and tomorrow we'll be having order by. So there are a lot of scenarios where we don't want our results to be vaguely ordered, but we want them to follow. Actually, this is the case a lot of times, because you would want the highest revenues or the lowest performing states. What will you do then? We'll have to order them by some clause. So we'll be using order by, which we'll be learning tomorrow, and building up our SQL knowledge further, getting ahead in our data analysis journey. I hope I'll see you all there. Have a great day. Thanks for joining. Bye.